Well, I don't understand it. I'll have to play it back. You're talking about dark matter.
Don't do that. No.
Okay.
But I'm going to eat your candy.
Okay.
Still malt? Robin eggs?
Malt, the ones Grandpa likes.
Robin
malt
eggs.
balls.
Yeah, the robin eggs.
Yeah, that's what they're called.
Anyway, so they thought that it might, just be stuff that's not giving off light, like dead stars or like large gaseous bodies that never got massive enough to make stars.
Mm-hmm.
Or rocky bodies, stuff like that,
Never heard of rocky bodies.
The Earth is a rocky body.
Oh, okay.
Yeah. And so it's stuff that's just not around a star, not giving off light, and it's out in like the halo of the galaxy. It's like, gravitationally it's in the galaxy, but it's not in the visible part of the galaxy, right?
Mm-hmm.
Like we are. We're in one of the arms of the galaxy, right?
Oh, okay.
Yeah. Stuff that's like either throughout that stuff you can't really observe because there's too much light around.
Okay.
But stuff outward. So what they did is they couldn't do this until you had computers. But they looked at this dwarf galaxy that's around us called the Large Magellanic Cloud, and it's just this small cluster of stars, a couple 100 million stars that we're capturing.
Mm-hmm.
And it's relatively still because it's so close to us, but it is pretty far away, but it's relatively close to us. We can see the stars all pretty well, so it's a perfect candidate for this. And what you do is you have a telescope look at millions of stars, because what you can do is you can either look at one star for about 1 million years, that's what the math would predict, that this would happen once per million years, or you can look at 1 million stars for 1 year. That kind
Does that work?
Yeah, that's how it works out. It's a probability thing.
Okay.
And what you do is you look for this thing called gravitational lensing. If you're looking at a star, and a body goes between you and the star, that body is going to grab a little bit of light that normally would miss you, and it's going to refocus it at you. So for just a little bit, that star is going to get brighter, and then go away. And there are stars that have variable brightness, like stuff like Cepheids, which I can't really describe what they are, but they do that periodically. So like every 10 days or every like 30 days, something like that. They'll they go through this process where they get brighter and dimmer, brighter and dimmer.
Okay.
But these ones from gravitational lensing, it'll only do it once, and it has this very characteristic like wave to it. And Cepheid variables, their wave is very different, so you can tell what they are. So they looked at this cloud of stars, and it worked. Like they saw them, but the thing is they didn't see enough of them for it to account for nearly, it's like a tiny fraction of the matter that they would need. So all of the dark matter has to be something else. They don't know what it is still, but they at least looked to see if it was just the obvious answer, which would be just regular stuff, and it's something else.
Well, you'll have to figure it out.
Okay, now I'm going to bed.
Okay, good night. Say good morning to
Morning,
Jane.
Jane.